Right, here is the second portion. Let's see, we have it right. Alright, so example problem number 7. We are given the parent function of a quadratic y equals x squared. So here is your graph of the quadratic parent function. And we are told that, why is that kind of weird like that? And we are told, I'm not sure why this is weird like that. We need to graph on the Cartesian plane. That's a Cartesian plane, right? If you wonder what that means, that's just what that is. We need to graph this function on that graph along with the parent function. So we have h of x is equal to 2, parentheses, x minus 1 quantity squared minus 4. So this is, we have to remember our translations, right? So inside, it's opposite of what you think. So when we're seeing a minus, it's actually going to be to the right, positive one, and inside is left or right, right? So this one will be right, 1 unit. Outside, what you see is what you get. So when you see a minus, it's actually going to go down. The outside is up or down, so this is down 4 units. And then the number in the front here, the coefficient, is going to be a vertical stretch by a factor of 2. Okay, so now that we have all of that figured out, from the parent function's vertex, we're going to go right 1 unit and down 4. So to the right 1 and 1, 2, 3, 4. So I'm going to be right here with my new vertex. The parent function goes over 1 up 1 and then over 1 up 3. We have a vertical stretch of 2, so all of that is going to be multiplied by 2. So over 1 up 2 instead of 1, and then over 1 up 6, right? Multiply everything by 2. And then we use the symmetry to do the one on the other side. 6, right there. And I'm going to kind of turn my paper because it's easier to draw this way. And there is my function, okay? Number 8. This is an absolute value graph. So the graph of f of x is given on the left. We need to write the function the equation that illustrates the graph. So I know this is going to be an absolute value, and the parent function of an absolute value looks like that. Technically, the parent function would be right there. Right, that would be the parent function, absolute value of x. So the graph I'm looking at has been translated 2 units to the right. So I'm 2 units right. Then it has been translated 4 units up, right? That's a 4. So 4 units up. And then it's being reflected and do we have a vertical stretch? Yes, we do have something because we go over 1, 1, 2, over 1, 1, 2. So there is a vertical stretch by a factor of 2. Goodness gracious. Okay, here we go. So parent function, that parent function is translated 2 units to the right, so that's happening inside, right? Left or right is inside. And because I'm moving towards the right, I need to see a minus inside. So let's do that already. So the parent function is going to be an absolute value, and I need to the right 2 units. So instead of doing plus, I'm going to do minus, opposite of what you see, right? Inside, 2, because it's 2 units. Then we go 4 units up. So outside what you see is what you get. So I'm going to say plus 4 to show the up. Then I have a reflection over the x-axis, which means I'm going to have a negative there and a vertical stretch by a factor of 2, so negative 2. And that will be, and they're telling me that this is a graph of f of x, right? So I don't pick the name I want for my function. They're actually telling me this is f of x. So there it goes, f of x equals. All right? Number 9, given g of x, so we have a quadratic, we need to write that in vertex form. And here you have your vertex form given to you. So if I need to write that in vertex form, I'm going to complete the square. So g of x is equal to, I'm going to factor out a negative 1 from both the terms that have an x in it. So I need a negative 1, and then x squared, and then positive 4 divided by negative becomes minus 4x. Leave a little bit of room for whatever we need to add to complete the square, and then your plus 5, just kind of push it to the side. Alright, so now we're ready to complete the square. So I'm taking my negative 4 divided by 2 squared, that will be 4. So I'm adding 4 here. But that 4 is being multiplied by a negative 1 here. So negative 1 times 4 equals negative 4. So if that's equal to a negative 4 and there is no equal sign between them, I need to do the opposite of it, so plus 4. Alright, so g of x is equal to my negative. And now I'm going to factor my trinomial here, so that will be x minus 2 quantity squared. And 5 plus 4 is 9, so that will be a 9. So this is my vertex form. So let's write it down. G of x is equal to negative parentheses x minus 2 close squared plus 9. We need to find the vertex. Well, once you have the vertex form, it's easy, right? That's my h, that's my k. So the vertex will be, 2, 9. Remember, opposite of what you see inside. So when you see a minus, it's actually a positive, right? So 2, 9. The axis of symmetry is always the x portion of the vertex. So write x equals 2. All right, number 10, we need to factor to solve. So factor first, then solve. So we're going to be factoring. There is a number in the front, so we need to do first times the last. So 2 times 3 equals 6. So what can I multiply to give me a 6 and add up to give me a 5? Multiply to give me a 6, add up to give me a 5. So it has to be 2 and 3, right? Because I have a number in the front here, I'm going to say, okay, 2x squared. And then the 5x is going to be replaced by plus 2x plus 3x, and then the plus 3. Don't forget your equal 0. And now we're ready to do the grouping. So we're going to see what those have in common. So 2x squared and 2x have a 2x in common. Divide 2x squared by 2x, you're left with x. 2x divided by 2x is a 1. What do those two have in common? Well, a 3. 3x divided by 3 will be x, and 3 divided by 3 will be 1. We have the same thing inside, so we know we're good to go. So now we look at what those two have in common. And by the way, don't forget to do your equal 0 back here. So what do those two have in common? Well, they both have an x plus 1. And then what will be left over will be 2x plus 3 equal to 0. Okay, so now it's completely in factored form, so we're ready to solve now. So we've done the factoring, now we're solving. Solving means we have a product, and it's equal to 0. So we're going to separate them. So we're going to say x plus 1 equals 0. And we're going to say 2x plus 3 equals 0. And we're going to solve those separately. So subtract 1 on both sides. Therefore, x equals negative 1. Subtract 3 and divide by 2 will be negative 3 over 2. So the factored form here will be what we said here, right? So that will be x plus 1, 2x plus 3 equals 0. That's your factored form. And then the solution will be the two solutions here. X is equal to a negative 1, comma, and negative 3 over 2. All right? Now, we keep going on our factoring journey. Here we have a cubic now. So when it's a cubic, we're going to look for a GCF. What do all of those have in common? Well, they at least have an x, right? So I'm going to factor out an x. So here I'm left with x squared plus 8x minus 20. And now I say, okay, what can I multiply to give me a 20 and add up to give me an 8? And that looks like it will be, well, 2 and 10, right? I know I need a negative when I multiply and a positive 8 when I add, so positive 10, negative 2. And since there is no coefficient in front here, I can go ahead and set up my two binomials already. I can use the shortcut. Don't forget the x we took out first. And this is your factored form. Here it doesn't say solve, right? So once you're factored, you're done. All right. We keep going factoring. Now that's a cubic, and for the cubic you're going to need the formula. So the formula a cubed minus b cubed is going to be equal to a minus b, and then a squared plus ab plus b squared. Okay, so if this is a quantity cubed, the cube root of that will be equal to 4, because 4 cubed is 64, and the cube root of this will be 3x. So we keep the minus, right? When we have a minus here, we keep the minus, and then 3x. Once the binomial is set up, now we go to the trinomial. And the trinomial says, take the first thing you just put in the binomial and square it. So take the 4 and square it. That will be 16. Then do a plus. And now take both of those things you have in your binomial, ignoring the signs between them, right? Just take the two terms by themselves and multiply. So 4 times 3x, that would be 12x. And a plus. And then finally take the second thing in the binomial and square it. So take the 3x and square it, will be 9x squared. And that's done. We cannot go any further. So this is going to be factored. Okay. Now we're going to solve using the quadratic formula. And so you have to recall that the quadratic formula is going to be equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. So we need to figure out what are the a, b, and c values. So the a is the number... No, not yet. Important. This is not set equal to 0 yet, so we can't decide what a and b and c are yet. It has to be set equal to 0, so we need to subtract the 4x. So we have 3x squared minus 4x plus 2, and now it's equal to 0. So now we can say, okay, a is 3, b is negative 4, and c is 2. You see how it's important, because if we wouldn't have done that first, we would have said that b is positive 4, and that would be incorrect, right? It would give us the wrong answer. So we have to set it equal to 0 first. Then we identify a, b, and c. Okay, once we identify them, now it's just a matter of substituting at the right place in the formula. So we need a negative b, so negative 4 plus or minus B, make sure you put parentheses and then square, right? Especially since this is a negative value. Minus 4 times A, and A is 3, times C, and C is 2. All of that is divided by 2 times A, and A is 3. Okay, we are going to do the discriminant first. The discriminant is what's underneath the root, not including the root, right? So I need a negative 4 squared. That will be 16. Then I need 2 times 3 is 6, and 6 times 4 is 24. And then I have a 16 minus 24, right? So 16 minus 24, that will be a negative 8. So negative, negative, let's simplify that to a positive, plus or minus. Okay, what did I say that was? 16 and negative 24, so negative 8. And 2 times 3 is 6. Okay, the square root of negative 8 can be simplified. I'm going to do that here. Negative 8. We can break that into a 4 times 2. And the 4 will come out of the root as a 2, and the negative will come out of the root as an I. So I would have the 4 plus or minus, right? And then remember the 2 came out as the 4 came out as a 2, and the negative as an I, so we will have a 2I, and then what's left inside the root will be that 2. All over 6. And now we're looking to see if we can simplify any further. On the 4, the 2, and the 6 all have a factor of 2, so we divide them all by 2. At this point, you need to recognize that this is one single term, so I'm not doing anything inside my root, right? Just by dividing this number by 2, I'm dividing the whole term by 2. So divide all your terms by 2 will give you 2. Let's put that up here. X equals gives you 2 plus or minus 2 divided by 2 is just a 1, so just I, and then my square root of 2, all over, and then divide 6 by 2, which is 3. There we go. Complex numbers. So we have some powers of I, and now we need to recall that I to the first power is I, to the second power is a negative 1, to the third power is a negative I, to the fourth power is 1, and then it restarts. So I have a 2 times I to the 6th. So 1, 2, 3, 4 power, 5th, 6. So I would end up right here. So that's a negative 1. So 2 times negative 1 plus I to the 11. So the 11 will be all the way to the 8th will be down here. And then 9, 10, 11, right? So negative I. So that will become a negative I. Then I to the 4th, so that's minus. And then I to the 4th will be this one, right? So that's just a 1. And then plus 3I to the 5th. Well, that's 4. 5th will be back up here, so just an I. So let's see what we have. We have a negative 2, a negative 1, and a minus 1. So that will be a negative 3 eventually. And then a negative I plus 3, that will be a plus 2I. And that will be negative 3. So that will be equal to negative 3 plus 2I. Let's put that here. There we go. We need to find the conjugate of the answer we just found. So this is our answer. The conjugate, we never change the sign in the front, right? That doesn't change. It's the operation between them that's going to change. So we keep that negative 3 there and the 2I, but the operation between them is what changes for the conjugate. So we had a plus here, so we want a minus. Okay. And now just a little application. If a rock falls from a height of 20 meters on the planet Jupiter, its height h in meters after t seconds is approximately h of t is equal to 20 minus 13t squared. I have a big smudge here. It's because just before I started recording I realized that I have a typo here. I have an x in my function when this is a variable of t, so you need to change that x to a t, otherwise that doesn't make sense. So negative 13 is going to be the acceleration due to gravity on Jupiter, right, which is different than the one we have on Earth. And then we need to remember to include units in all our answers as appropriate. So little a says, what is the height of the rock when t equals 1 second? Well, that's kind of easy, right? If t is my time in second, then I just need to plug that in here. So h of 1 when t is 1 is going to be equal to 20 minus 13 times 1 and then squared. And that will be equal to 7, right? Because that's a 1, 20 minus 13 is going to be 7. And so we're going to say, therefore, the height of the rock when t equals 1 second is 7, and we're measuring in meters, so 7 meters. Okay, then B says, when is the height of the rock 15 meters? Well, if h is height, then we're going to set the equation equal to 15, right? So 15 equals, and then 20 minus 13 t squared, and now we just solve for t squared. So we subtract 20 to both sides, that will give us a negative 5. Then we divide by negative 13, so we have a 5 over 13, right? So negative divided by negative will be equal to t squared, and then we will take a square root on both sides, and t will be about, let's take the calculator for that one, and the calculator is going to tell me, let's see, about, and we're going to go 3 digits after the decimal, so about 0.620. Now, what does that mean for our rock and the situation when the height of the rock is 15 meters? When does that happen? It's at time 0.62 seconds after release, okay? And I just said that, so I'm not going to take the time to rewrite it right now. I'll rewrite it when the video is over for the sake of time. When does the rock strike the ground? Now here I'm going to use my calculator. I'm going to go to my graph page. I'm going to type in my equation. So the equation was 20 minus 13. In the calculator we have to use x, right, as opposed to t. So I'm going to say x squared. That's my equation, right? That's what my equation is here. So that's what I typed in. I do not see the height, the maximum height of my rock, but I really don't care because I want to know when it hits the ground, meaning I'm looking for this x-intercept right there, right? So I'm looking, this is called a 0, so I'm going to go menu, analyze graph number 6, and I want the 0, number 1, and then I'm going to bring that line close to it, click and pass it and click. I want 3 digits, so I'm going to bring the hand over it and hit the plus key, and it's going to give me more digits. And so the rock hits the ground, therefore the rock hits the ground at t is about 1.240. And what is that for units? So t is about 1.240, and that's in seconds. Oh, by the way, I didn't put my unit here. That's in seconds also. Okay, and that's it.